Okay, hey, everyone, it's me, Ben. I'm here. I'm doing a thing. I hope everyone's having a good conference so far. It's only day 2, which is horrifying. I feel like I've been here for a week. So today, as I said, we're going to be doing a work-along where we're going to be building an API with PowerShell and Azure Functions, because if we can do it, why not? I've been spending the last year and a half of my life working on a project that's taken me away from my love of PowerShell, and I'm now working with nothing but C#, doing minimal APIs and building all that fun stuff. And I was just kind of like, the call for papers came out, and I was like, I wonder if I can do what I do in my day job in a fun way with PowerShell and see if we can sort of do a parody to what we have with minimal APIs with PowerShell and Azure and all the fun things that come with that. The answer is, absolutely yes. Should you do it in production? Probably not, but you can, so we can play around with it. We're going to go through the pitfalls of why this is good, why it's bad, some of the things we can do, the little more advanced interrogation of what you get with an Azure function and PowerShell in general. I am not an expert by any means on this stuff. I just do it a lot because I really enjoy it. I'm sure that there are a lot more people in the audience that know more than me about this stuff. So if anyone wants to call me out on an incorrect statement, please do it. So let's just get started. Many thanks to the sponsors. As always, Chocolate is great. Centrino Systems, Script Runner, whoever Patch My PC is. We all do stuff. It's great. They make this conference what it is today. Okay, a little bit about me in case no one knows. My name is Ben Reeder. I'm from Australia. I'm still jet lagged, always. I write the software for Patch My PC, which is primarily just an automation solution to get software updated and pushed out to your environment. I'm on all the social media things that are not LinkedIn, because LinkedIn bores me. Twitter, while it's still around. I have a website, powers-hell.com, and I put all of my code, including this stuff today that we're looking at, on GitHub. So please check that out. Okay, quick summary around what we're going to do. I've kind of already gone over this, but essentially, we're going to be building a full create, read, update, delete API solution in PowerShell in Azure. You don't need to follow along with what we're actually doing today, but the framework for this will help you get started so you can build a basic just like data ingress and egress solution, and then you can build on that. So we're going to very loosely plan what that looks like. We'll talk a little bit about the methods, things like that. Just to show of hands here, who currently works with Azure Functions just in a day-to-day? Okay, that's a lot less than I thought. So probably a little less than half. Who has got experience with Azure Functions outside of PowerShell? Even less. Okay, cool. This will be fun then. So once we've planned the thing, this is literally just a mind map, right? So we're just going to go through, okay, I have an idea. The idea is we're going to build a to-do app because it's very simple. It holds state, it holds data, we can change things, but the concept there is solid. So we want to plan that out, even just on a piece of paper, we figure out what we're going to do. We're going to set up the infrastructure in Azure. We could do that all PowerShell-y and fun, but I'm just going to do it following the UI because it's easier for the session. We're then going to create our development space. There's a couple of different ways we can do that. Because of limitations of Conference World, we're going to be doing some weird stuff. But there's many ways that we can actually work on this. Then we're going to create a local function app on our machines. Right? This is where things will probably not work and everyone's going to freak out. And Scott's going to get very fit. He's going to run around. And then we're just going to test things. We're going to develop the API locally. Everything that we're doing today is fully local. Show of hands, who doesn't have an Azure subscription right now that they can use? Okay, cool. I am going to put up the keys and all of the access to the storage solution that I have so that you can build it locally and you can still send data into the table. So don't swear in things when you put it in because it will come up on the screen. Okay, what else are we going to do? I've said here that we're going to show how we can deploy Azure with ADO pipelines and GitHub Actions. We might not get to that, but if we run out of time or if I've run out of content, then we can definitely dive into it. It's very, very easy to do, but we can also deploy the thing that we're working on from VS Code really easy, so I'll show you that. It's a much more secure way than writing the code in the Azure portal. You should never really do that. One of the net benefits you get from deploying from anywhere but Azure is it locks the function app from the portal so that you can't make changes in the portal. So it just sort of locks it down and secures it a little bit. And then finally, one of the most important things about this, when you're tool building your API, you generally start with a very simple mission statement, which is, I want to do a thing. I want to store a thing and then change it and read it later. When you start building PowerShell modules, PowerShell functions, APIs, all that sort of stuff, you very quickly get to the point where you're just like, boy, this is a really good idea. I wonder if other people would find value in this. So an API is nothing unless other people can ingest it and use it. So we're going to look at a little bit around if we can build a full stack API solution in Azure with PowerShell, how can we generate the open API schema that allows other people to build clients to use this thing? I haven't done too much into this. I just got very excited about the concept because this is a thing that is just ingrained in the C# world, in the .NET framework world. So surely we can do it. It's all built on .NET, so why can't we do it? So we're going to have a play around. I haven't touched it that much. It might not work. It might work. It could be cool. So we're just going to see some of the things that we're doing there. Okay. API Planner Design. So we're going to build a CRUD to-do app. CRUD is my favorite acronym. Create, read, update, and delete. It is everything you need to do to a piece of data to store it as much as a database can be done. So what are we going to do with our CRUD to-do app? It's in the acronym. We need to be able to create an item or an entry in the database. We need to be able to read that database. We need to be able to update any entries in there, and we also need to be able to delete them. So they're our primary frameworks that we need to sort of build endpoints for each thing. So let's have a look here. So this is what we've got. So first and foremost, we've got a database with nothing in it. So we need to fix that, right? We need to create a new task. So that is a post method for a HTTP call. And that path there, and again, this is just mind mapping. You could call it whatever you want, but we're doing a to-do list, so we're going to do that. So the path is just to-do. So I'm going to do a post on to-do with some kind of data, and it's going to end up in a database. Cool. The next thing we're going to do is list all the tasks. So anything that's in the database, I want to see. We're not doing paging or anything like that, but you can absolutely do paging if you need to. And obviously, for that, we're just going to do a get against to-do. The next thing we do, okay, now we've got 400 items. I don't want to get 400 items. I just want to get one item to do a thing with. So then we have to start thinking about, well, how can we grab that one specific thing? And that is where custom routes in Azure Functions come in. So we can start going, well, let's sub out the ID value on a to-do. So this is a different endpoint because the route, the URL, is a different thing. It's worth noting that if anyone's not building APIs, all endpoints are just web URLs. So when you have a different URL that you need to build, unless it's dynamic, then it's a new endpoint. Okay, so we've got a specific task. The next thing, it's a to-do app. So what do you do with a to-do app? You put in a list of groceries that you need to get from the supermarket, and then you check them off. So we need to change the state, or we need to toggle the state of that to-do item so that we know that we've already completed that work so that we don't go back out for beer because we've already got the beer at home. Finally, we're going to update the task because you misspelled it correctly because no one knows how to use a keyboard. So we need to be able to go in and update that task without potentially changing the state of it. And then finally, we need to be able to delete an existing task. So once you're completed, everything in your list is completed, we want to go through and just delete those one by one. Make sense? Yes? Silence. Excellent. Okay. This isn't working again. It's gone to sleep. 1 second. Hell yeah. Okay, so as I said, we've got different endpoints here. So anything that looks the same will be broken up into its own Azure function app because it needs the route itself needs to be unique per function app that we create. So we've got the to-dos, which are just the global, like we're going to create a thing and then we're going to get all the things back. And then finally, this is still not working. I'm just going to press enter. Then we've got the final thing, which is just item-based building. Oh no, it's working. I just can't walk away from the computer. Cool. Let's go back. All right, so again, get, post, put, and delete on specific items are their own function app. So we'll have one thing for all the items and new items, and then we'll have another thing for specific items based on the ID of the value. Okay, so what do we need for this? Again, this is the thing. I put up a thing yesterday. Almost no one downloaded the content. That's fine. It's on me. But we're going to go through, and we need some things on our computer to do this. So what do we need first of all? Well, we need to build and create an Azure function app in Azure. For the people that do not have an Azure subscription to work with, it's fine. We can build the infrastructure locally and test that it works. And then once you get access to stuff like that, then you can actually deploy it and play with it. But functionally, we're going to do this locally. On the session that I did yesterday, hands up who went to that? That's awesome. Okay, cool. I did not get enough time to talk about managed identities in that session because I talked way too long, which is very funny. So we're going to spend a little bit of time working around managed identities and how we can actually access other resources in our function app without storing credentials anywhere, which is really, really cool because every single person in this room at one point will put a secret or a password in a source repo and put it up into GitHub and then go, what do I do? In fact, I had to delete my repo in GitHub because I did the exact same thing I'm talking about. So we're going to use managed identities to get away from that. And I could talk about this for probably 2 hours. So we're going to play around with that. I'm going to show you some of the cool things you can do with managed identities. What else do we need? So we're building a to-do app. We need somewhere to store this data. I don't want anyone to really have to pay any money for this. So we're going to use a storage account that you get essentially for, when I say free, I'm saying free with the giant asterisk here. It all costs money, but we're building a consumption-based Azure function app, which is basically you pay for every single time you hit it, and you get 50,000 free runs a month. So this can almost run for nothing. With that, you get a storage account that costs a little bit of money to do ingress and egress, but with a storage account, we can build up an Azure table. An Azure table is baby's first NoSQL. It's essentially unstructured data in JSON format that just lives there and you can do things. It is the precursor to Cosmos DB, which is a fantastic solution, but costs are astronomical. So for prototyping things, Azure Table is really good. Once you get a little more advanced with this sort of stuff, you're going to probably want to start looking at better database solutions than Azure Tables, things like MongoDB. Or we can even go down the route of SQL. But unstructured data is really easy for this sort of stuff because PowerShell doesn't have to be super type safe with the data. Okay, so we're going to set up the permissions in the storage account so that we can use the managed identity. The function app can look into the storage account and actually do things without us having a credential there. And then the Azure table, obviously, we need to give it a name. It's a to-do app. What do we want to call it? Okay. The next thing here, this is the controversial one. So I am doing this demo on a Mac. I generally don't like Macs. One of the projects that I'm working on at work at the moment, I tried to convince everyone that the stack that I was building could run on anything at all. And everyone didn't believe me, and they said, ha, 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 well, good luck. So I said, okay, well, I'm traveling a fair bit this year. Buy me a Mac and I'll prove that I can do not only development, but I can also do all of my conference sessions and everything on the device, completely agnostic of what it is. Sure enough, my project that I'm working on is totally fine. My demos are not. I'm having a very strange problem with dev containers. Hands up, who knows what dev containers are? Okay, this time next year, there's going to be twice as many people. So dev containers essentially allow you to say, hey, I need a bunch of software in my environment, but I don't want to look after it. I just want it to always be the same so that I can build my solution. That essentially creates a container in your environment, and then you use VS Code as a front end to access a server instance running in a container with everything you need to work on your solution. So it doesn't matter what computer you're on, you're going to have the same experience. It's really, really cool, and it is free. It costs nothing but the electricity on your device. You need Docker Desktop, you need a bunch of things to get that running. Again, they're all free for just standard use. So that is a really, really good way to do that sort of stuff. But when I'm not going to do that today because my laptop is not working. Scott has it working in a dev container. So if anyone wants to just lean over and look at what he's doing, we can definitely do that. What I hope today, I will try and explain. I want you guys to do it locally because the dev containers are cool, but it does end up pulling down like 2.5 gig of data to spin up the container. And if every single one of you do that, the internet might not be happy. And I don't think Gail will like me very much. So we're not going to do that today. The other option that we've got is code spaces development. So it's, this is the gold standard for development on any device. You install nothing, You go to your GitHub repo, you spin up a code space, and everything that you need is just there. Please note that there's a lot of dollar signs there. This one costs money. Unless you get free access to things through MVP stuff, or you're lucky that your business will pay for it, this does cost money, which is why, as much as it's cool, I'm never going to recommend anything that costs money in a workshop scenario. So again, we're going to do local development. So there's a couple of things that we need today, and hopefully by now, everyone's got most of these installed. So at the base level, we need VS Code, we need PowerShell 7, we need to install the Azure Functions core tools, and then we need to install the extensions locally in VS Code that we need to actually sort of build this stuff, and we can have a look at what those are. Let's see what else I've got here. Okay. Note how I've got this highlighted. It's not what I'm doing. We're going to do the local development one. So pretend that's changed. Okay. That's it for slides. We're in development. We're in demo land now. Okay. So we have two options for everyone to follow. You can clone my repo and follow along. That's the link there. Or you can start a new repo on GitHub if you're brave, and you can follow along as well. My strong suggestion is to go to mine, clone it down. I've got it set up in a semi-structured way. I'm going to give everyone a couple of minutes to go there and clone it. You were such a polite crowd. So the question was, is Docker Desktop free for enterprise use? The answer is no. This is an enterprise use. In your day-to-day, if you're doing local development for a proof of concept that doesn't go to prod, you're all good. Obviously, I'm not a licensing person or a salesperson or have any affiliation with Docker Desktop, so take it with a grain of salt. But if you're doing community stuff and you just want to play around with the thing, absolutely. I also believe that depending on the size of your company, that does not count as well. So please verify that. Okay. I'm just going to give everyone a couple more minutes. Again, if anyone's got any problems accessing the repo, please sing out. You're all being very, very quiet. All right, one more minute. While we're waiting, I'm going to take a photo. Is everyone ready? Very good. Okay. Is everyone good to go? No dramas pulling down the repo? So quiet. All right. Where's Justin? Oh, he's doing another thing. Okay, cool. Okay. Well, that was fast. All right, demo time. I get to close this. All right, so the first thing we need to do is, well, so normally we would do I'm going to show you the dev container stuff. We're not doing the dev container stuff, but I think it's really cool. And I just want to show you functionally what we can do with this. So I've got all of the tools that I need on my machine. Potentially I could build it there, or I can do code spaces. But I'm just going to kind of show you all three things and get lost and figure out where we're going. So we're going to open Visual Studio Code on my machine. So I have got my main branch. For everyone that's following along, who doesn't have the GitHub extension pack installed on their machine? Okay, there's a couple of people. Please just go to the extensions now. If I can make this a bit bigger. Is that better? Everyone can see that? Yes, cool. Okay. Git extension pack. It's that one there. Git extension pack. Install this. It's really invaluable. This is not for dev containers. This is just a thing that you should have on your machine. It just ramps up your usability of Git and development in VS Code. So please get that installed. The key thing that I just want to point out here for everyone that's following along, or even just the people that don't want to tease me on stage and just want to sticky beak on the solution, I've got this broken up into multiple different branches. If I go into my branch list here, so I'm currently on main, and then I've got them numbered. So I have 1 is just my dev container, 2 is my Azure function, 3 is the to-do app, 4 is the ID routes, so the custom routes, and then finally 5 is the completed solution. So if all you want to do today is just look at the completed solution, download the repo, change the branch to number 5, have a look at it. You can spin that up and it will start working. There is one file that you need to get. We'll get to that in a second. Okay, so I'm in the main repo at the moment, just to show you one thing, that I have nothing installed. There is nothing at all. I have a cheat sheet to remind me of what to talk to you about, which I'm going to constantly go back to. But essentially, the repo is empty. So we're now at a point that if I was doing a dev container example, I could show you specifically how you could build that. I'm going to show it just because I think it's cool. And this is what you should be doing when you're developing these things locally anyway. Because one of the biggest problems with when you decide to start developing Azure functions with PowerShell is the function CLI tools and the core tools all get updated so quickly that within a couple of weeks, your local development environment is out of date and everything you're building is out of date. With dev containers, you can just change what you're pointing at and you get all the new tools without having to install them, which is fantastic. So I'm going to quickly show you how we do that. So I'm just going to go into the command palette, container. I'm going to add dev container configuration files. We're going to go in and we're going to show all definitions. And we're going to search for PowerShell, PowerShell dev containers. We can choose to install some other things if we want to. Go through this experience if you can. There's a bunch of stuff that maybe you might need in your environment. For now, we don't, so I'm just going to leave it. It's going to add those dev container configuration files, which we can see here. So I have devcontainer.json. Very exciting. So what we can see here is that we're building a Docker instance. There should also be a... Oh, it probably wants me to... Okay, I'm going to quickly change over to the branch that I already have this built in, just to show you the finished dev container. Yeah, nice. Just quickly commit all these changes. What could possibly go wrong? That's what he said. Okay, so here is the next branch for anyone that's following along. It's number 1 dev container. So in here, again, I've got this devcontainer.json file, and then I've got this Docker file thing here. The devcontainer.json is the full actualized version if you wanted to try it on your machine. It's got a couple of things that are kind of cool about it. So what are we doing with the dev container? Well, we're going to build our dev container. How do we build it? We're going to point it at a Docker file named Dockerfile. Awesome. I've put in a little extra thing in here. So by default, when you run a Docker file or a dev container, it just gives it an arbitrary name because it's an ephemeral container. Doesn't matter. When you finish, just throw it away. If you want to work on it again, pull it down and generate it. So you don't need to name they're not pets, they are cattle, right? This is just things that you throw away. If you want to give it a cool name, you can put in this runargs thing, -- name, PSConfEU 2022. Hey, it's not 2022. It's 2023. That's cool. Dev container. So when I build my container, it's going to be named that, so I can actually see and track that. So that gives you a little bit of help when you're sort of building things, and you can actually look in Docker Hub and know what you're actually building. Couple of other things. Azure Functions locally builds and runs on a port that is 7071. So we just need to poke a hole in our container for that. Then we've just got customizations. This is unique to VS Code and remote development. Essentially, what we're doing in here is we want to make sure that by default, our terminal is running in PowerShell, because that's why we're at this conference. And we also want to make sure that we've got a couple of extensions in our container that will make our lives easier. So if we just have a quick look at this list, the first one is pretty obvious. It's Azure Tools, VS Code, Azure Functions. It is all the things that allow you to build and develop and deploy Azure Functions in VS Code locally to your Azure instance. The next one is even more obvious. It's PowerShell. We need the PowerShell extension to get all the fun autocomplete and IntelliSense and formatting and all that sort of fun stuff. The next three are what I install to make my life easier. So I install Thunder Client, which is a very, very lightweight REST API tester that lives in VS Code. I'm going to use that a lot today. That was in the list of things that I asked you to install. So if you are following along, you should already have that. The next thing, Git extension pack. We went over this. It gives you a whole mess of extensions that make working and committing source in VS Code just brain dead easy. So please install that. And finally, just because everyone keeps talking about AI, we've also got Copilot chat. I get it for free. I think it costs money. Someone needs to look that up. But Copilot is fantastic, and it makes working on this sort of stuff incredible. It basically replaces your IntelliSense with a robot that almost always tells you the wrong thing. So it's fantastic. We love AI. Okay, and then we've got a couple of things that we're going to do after we build. Again, like everything aside from the extensions here, I have not changed. So I just added in a couple of quality of life things for myself. Post create command, what are we going to do after? We're going to do a .NET restore. We're basically running a C# thing, so maybe we want to do that. It's commented out, but it shows you what you can do. And then finally, we set up a user account that we're going to be essentially running this container as. This is just default. It's VS Code. You don't need to really worry about that. In the Docker file, this is the thing that we're actually building initially. Now, I've modified this from the default that you get when you create this by default, just to show you that there's actually a whole bunch of different Docker images that allow you to dictate what you actually want to build on. So if you don't want to be on the bleeding edge, you can actually go through and check out alternative images. So what I'm doing here is I'm just setting, well, I want to make sure that my Azure function is going to be running with the latest PowerShell binary. So it's 7.2 is the current latest one that we can use in Azure Functions. And then also I want to make sure that I'm using the function core tools at the latest version, which is currently set to 4. If for whatever reason you needed to use 3, you can set it to 3, you can set it to 2. You've got access to all of these things. This is just dynamically building the Docker image URL so that when we run Docker compose or run, it's going to pull down the correct instance and then build everything for us. There is a whole bunch of stuff on this. I think I've got it in my cheat notes, so let me just open that up. I do. Man, I'm smart. Okay, let me click on this. That is not what anyone said. Okay, let's have a look here. Azure Functions, Power Tools. Full tag list, just to show you. So by default, so the one that I am using, would be using, is 4-PowerShell 7.2. By default, you don't get that. You get just 4, or maybe it's even 3. I can't quite remember. But essentially, you've got a whole bunch of options here. So if you know that you need to build in a specific framework, then go and be very specific with what you're pulling down. Also, these change all the time. So if your local environment starts to get out of date, instead of having to uninstall or find the installation files for all of the new things, you just change this file and rebuild your container. It's absolutely incredible. Okay, well, let me check my cheat sheets again. Okay. This was a joke saying that note that PowerShell is already out of date. So as soon as you open the dev container, and I'll do this in Codespaces just to show you what actually happens, you get a prompt saying, hey, 7.2 is not the newest version of PowerShell. Do you want to update it? There's currently no way to do that there's no image with the latest version. So that will change eventually, but I just found it very funny. Okay, so let me just show you how we're going to build the dev container in Codespaces, because I'm going all over the place with different ways to do these things. Go into GitHub. I need a new photo. All right. API. Okay, so again, who here has played with code spaces before? Ooh, that's really not that many people. Okay, so check this out. I've got a repository with, this is my main branch. I probably want to go to, let's go to Azure Function. My second branch. I've got a dev container in here. April, who is here, starts almost all of her sessions with a project is not a project, or a GitHub repo is not a GitHub repo until it has a dev container. That is the truth. Even if you're not using this, it lights up a bunch of stuff in GitHub so that you can actually start building code spaces, gives you access to dev containers locally. It just lets you build on a machine. So if this caught fire, in theory, I could grab Scott's laptop and I could just continue working. Because I have this dev container, it means that this device is a throwaway disposable object now. And that's what I want my device to be. I don't want to fall in love with it and be a thing. It's just a disposable device. So what I'm going to do now is I'm just going to go into code. So this is where you would just go in here, you would just clone, right? And you pull that down onto your machine, which is what every one of you guys are doing right now. But I'm going to go into code spaces. And I'm going to go, so I've already got one running, but I'm going to build a new one because I like chaos. Code spaces. All right, I'm going to create a code space. So this is setting it up. So it's doing everything that I would do on my laptop, except I ran into a fun little bug, so I can't do it. We can talk about that later. Let's just watch this for a little bit. I apologize that it's in dark mode. I can't change that right now. But this is how we keep the bugs from coming in, right? Okay, let me open up the logs. One of the net benefits of using code spaces in conference land is it uses someone else's internet to pull the things down, so it's nice and fast. Ish. It might prove me wrong. Okay, while this is going, let's go into the infrastructure side of things because it'll be finished before we're done there. So one of the steps that I said was, so once we've designed and we've planned our routes, question. It's running in the background. I can always come back to it. Oh, sorry. What happens if I close this tab while I'm building the instance? Essentially, it is running it's like in a virtual machine, or there's an agent running doing that work. It is not specific in my browser. So if I closed it and reopened it, it would be complete eventually. It's done now. So this is my resource. I have a fully functioning instance of dark mode VS Code. Hang on, theme, color theme. That's good enough. So I have a full instance of VS Code. So I've got a terminal. I've got all of my extensions. I've got all of the things. I can develop and build this thing from my browser. And it took as long as it took. And that was a 2.5 gig thing that got downloaded and set up for me. So this will exist for as long as I need it for. If it's not running for a certain amount of time, it does age out and delete. But the point is this is a throwaway instance anyway, right? The code is what is important, but the actual run host is not. So that's how that works. Okay, so this is cool. This is working. We need to go back into Azure quickly, and we need to set up a couple of things. I'm just going to show you just the sort of the warts and all process of creating the Azure function and getting the storage account set up. Okay, so let's pop over to my Azure account. Now, I already have one set up, which is the one we're going to use, but I'm going to create one now for you just to show you how this works. So in Azure, I'm going to go into Function App. We're going to create a new one. We select our subscription. We select a resource group. We're going to create in the existing one that I have, 2023. I'm so smart. Okay, we give the function app a name. We're going to go real-time API demo. How do we want to build it? We're going to say, yeah, we're just going to build this as code. You can do a container image. It doesn't matter. It all runs the same. What's the runtime stack? This is where the idea of the image that we use for our dev container comes in. So it needs to match what your infrastructure is. So in this scenario, I'm going to say PowerShell core. What version do you want? 7.2. Absolutely. Region, point to the nearest region. Operating system. You can do this on Windows or Linux. Doesn't matter. It's PowerShell core. It can run on anything. As long as the things that you're doing do not rely on specific Windows libraries, use Linux because it is faster. It just is faster. I'm going to keep it on Windows for now, just defaults. And then we have a couple of hosting options. This is where the money side of things comes in. For any development things or just any little tools that need to run in the background and you don't care that it maybe takes a little while to spin up the first time, do consumption. As I said, you get 50,000 runs per month for free. That can arguably mean that if you're doing a thing once a day, then you're never going to pay for this to run. So it can do some of those arduous tasks for you, and it's just going to run. So we're going to do consumption, but you can do functions premium, you can do an app service plan, whatever you need to do. You go into storage. So we're going to create a new storage account. So this is important because the storage account is where the table is going to live. So we're just going to keep it as defaults. Networking, public access. I want everyone to get access to this thing and just go crazy with it, right? So I'm just going to say on. Obviously, you don't want to do this in a production environment. You probably want to limit it to maybe a VNet that you've got in your internal work, but you can figure that out. You can also hide this behind authentication, so you can have it public and then make it essentially with an auth wall in front of it as well. Monitoring, we've got an option for app insights. I'm just going to say yes. I'm just going to keep all the defaults. Deployment. We've got a couple of options for GitHub automatic continuous deployment. So I said that I probably wouldn't talk too much around CI/CD pipelines around this stuff. I will after this session if you want to talk about this more. But by default in this, you can set this up. It's really, really cool. But we're just going to say disable for now. But we can point it to our GitHub account and it will just constantly, whenever there's a change, it just updates the function out for you. Next is tags, which we're not going to do today. And then we'll go create. See how long this takes? But essentially, we're now building the function app as well as the storage account and putting it all in a nice resource group that we can build things. It's in progress now. We'll see how it goes. And while we're waiting there, I'm just going to refer to my cheat sheet. If I can find it. Oh, not that one. Okay. So we're just waiting for this to run because I want to show you a couple of things around the managed identity. Actually, no, we won't do managed identity straight away. You can tell I planned this, right? Okay, it's done. We've got an empty Azure function with a storage account now. So that's the first part of our infrastructure build. We now have a resource group, we have an Azure function, and we have an empty storage account. It's not going to do anything. There's no code here. It's not going to build. It's not going to even do a hello world. It is an empty shell. We need to start filling this thing in. What we're going to do is we are going to go in. We're going to set up the managed identity, and we'll come back to that. Can everyone see this is fine size-wise? Hell yeah. Thumbs are good. Okay. I'm going to go in. I'm going to set a system assigned. We have multiple options for managed identities. For now, we just want this managed identity to exist only for this app. It is not going to be used for anything else. It cannot be used for anything else. It is a fully self-contained managed identity. Microsoft manages the credential side of things so that you never need to know or accidentally leak the password. I had a conversation after the session last night about, it's nothing secure. No, that's correct. If there's authentication, there's always ways to leak credentials. When you create a managed identity, there is essentially a environment variable with the identity always in the app registration. So if anyone gets access to the thing, you've got bigger problems because someone's in your Azure tenant and they're poking around, but they can drain environment variables like any app. There is always risk associated with authentication, but this moves risk from you doing silly things. So it protects you a little bit from accidentally committing passwords. Okay, so we're just going to hit on. User assigned allows you to use the same identity for multiple things. And essentially, you can track who that managed identity is when they're doing other stuff. Does anyone have any questions at this moment, or are we all very confused? All very confused. Excellent. That's what I want to see. Let's hit save. Okay, we've got our managed identity. I have an object principal ID. That's all I need to do to use a managed identity. If I want to do stuff with it, I need to obviously call that, but I now have an identity. Whenever this runs, it's going to have a credential, so I don't have to put in a secret. I don't have to put in any sort of scenarios like that. The next thing we need to do is we need to set up the managed identity to get access to the storage account. So let's see if I can remember what I need to do here. Otherwise, I'm just going to show you how to do it. We're going to go into real-time API demo, function app. Come on. Oh, I did that the wrong way. Resource group. Okay, now I have a whole bunch of stuff in here because I've got a whole bunch of demos, and I'm not going to be able to find the storage account, so I'm just going to show you the one that I've already done. Storage account. Oh, and they're all named so well. Let's see if I can find it. Come on. Okay, this is the one. So what we need to do to actually use the identity, let me see if I can find it. It is PSConf 2022. Must not be this service. I apologize, everyone. I might have just shot myself in the foot. Let's try the top one. Boom. Nope, this is it. Okay, so we need contributor access. Should have written this down. I'm just going to go add. I'm going to do this now. We need to go into add role assignment. We need to find storage blob data owner, I believe is the correct role that we need. So this gives the managed identity full access to the storage account so that it can go in and actually work with the Azure table. So again, without logging in or anything, you already have the identity. So when you make calls to the table, it just knows, hey, I am this managed identity and I have access to this table. So it's going to go in and it's going to be able to do the create, the read, and all that sort of fun stuff. So we just want to make sure that's there. We go in and we select that and we go next. We select managed identity instead of a user. And we select members. And we select function app. You can actually see all of the different function apps that I currently have that have a managed identity. So if we just go and find, it's probably PSConfEU API demo. That sounds right. That wasn't the one? Oh, that's the real-time demo one. Yeah, sure. Let's just add both. Chaos, right? All right. So those are there. We go review and assign. We're going to add those. So now we have these managed identities that are allowed to do things with the storage account. The next thing we need to do is we actually need to go in and create the Azure table. Let's have a look if I'm in the right one or not. Let's go into storage browser. Or actually, no, we'll go into tables. So we're in the storage account right now. We're in a storage account. I'm going to go into tables. This will tell me, okay, so I'm in the one that I've created already, which is good. But if we want, if we have a look at the previous one, which I'm not going to because that's going to be a whole thing, you would see that this is empty. So now that we've created the shell of our function app and we've got our storage account, we need to go in and we need to create a table. So we simply just go in here and we go, hey, it's a table. Oh, we go, okay. So cool, now we've got a table. We go in, we can actually look at this in Azure, which is kind of cool. Instead of downloading Storage Explorer on our machine, we can go, hey, it's a table. There's nothing in it. but we've now got a database. It's just NoSQL. It's just key pair values that get stored in an instance of this. Again, it's very, very cheap. It's almost free. I don't know the exact pricing, but you're essentially just paying for ingress and egress on the thing. So this is really, really good for development scenarios. Again, if I have a look at my to-do, there's nothing in here. I had Scott test this out, and then we deleted everything. So that works, which is cool. Okay, so now we've got all the infrastructure we need. We have our managed identity, we have our Azure function, and we have our table. So now we need to just write some code to make the thing work. And I have done that in 44 minutes. That's not bad. Okay, any questions so far, or are we all still very confused? Excellent, that's good. It's day 2. If you're not confused, yeah, you haven't had enough beer. Okay, let's have a look at my cheat sheet again. I'm gonna not use code spaces for this. I'm gonna go back to this instance. Okay, so what we're gonna do is we're gonna create the function app locally now. So for everyone that wants to follow along, you've cloned down the repo, yeah? Excellent, this is all going very well. Make sure that you are in Azure function. Actually, no, let's go into, let me have a look here. One sec. Azure function. Oh my God, what is happening? What? Chaos. Someone asked if Steve Hoskins was here. I think he might be in spirit. Okay. Okay, I'm going to go back one. So if you go into dev container, number 1 is the branch. We've got nothing in this instance. What we want to do is we want to build our first empty function app. So again, you don't need Azure for this, but what are you going to do with it if you don't have Azure, right? This is all Azure stuff. So we're just going to go into the command palette, which is Control-Shift-P or F1, and we're just going to go functions. Let's have a look here. I can try. Let me give 1 second. Is this okay for everyone? Okay, great. So we're going function, new, create new project. Okay, you get this with the Azure Functions extension in VS Code. When you install Azure Functions extension, for anyone that just did it, it will also tell you that you need a bunch of other things to get installed. So it will actually install all the things for you. But we're just going to create a new project for now. I hope. Okay, awesome. By default, it's just going to put it in the root of your project. I want to be a little more controlled with where I'm deploying things, so I'm just going to hit browse here, and I'm just going to add it to a folder called source, or SRC. Enter a path that exists. Let me just create a path that exists. Okay, now we're going to define what our language is. Obviously PowerShell, right? The next thing it asks is, what is the trigger for this function to run? So this is how you're actually going to poke the thing to make the code run. In demo land, and specifically for an API, this is almost always going to be a HTTP trigger. Now, you can do this in a bunch of different ways. You can do it as a cron job. You can do it as when things hit a storage account, it triggers the function to run. But for the purpose of what we're doing today, it is a HTTP trigger. Okay, we're going to give it a name. I'm just going to keep it as default for now. We're going to go in. This is the next thing. So this is the authorization level. So by default, when you create a function app, it will just generate a generic code that is kind of like a key, so that if you don't have that key, you can't use the API. So there's a very low level of protection enabled by default for this. We're just going to say, yes, we would like function. If you want everyone to use it, which you don't, you can select anonymous. Again, don't do that. It's going to pull some stuff down. We'll give it a second. I'm just going to full screen this bad boy. Okay, finished creating project. So now we can see over on the side here, hopefully everyone can see. Oh, also we got the thing. Hey, PowerShell 7.2.1 is out of date. which is very funny. We're not going to worry about that for now, because that's what we want. Okay, so we can see here that we've created our HTTP trigger 1 function app. Inside this, we've got a bunch of stuff. Run.ps1 is the entry point to the function app. This is what is actually going to go through and run your code. There's a couple of other really interesting files in here that we can have a look at. But the important thing that I just want to point out here is that by default, it builds a kind of like a hello world scenario. So we can actually test this out. So let's just run it locally for everyone that's following along. Let's run this locally and see what we can do. So quickly, we have a parameter. So our param block has a request and some trigger metadata. We can dive in and actually look at what that request stuff is in a second. It's going to put a little bit of logging out to the back end so that we can actually see that a function request was triggered. And then we're just going to do a basic, hey, who are you? So we're looking for either a query or a body name, and we can look at that as well. Okay. Finally, if we don't have anything, we put in a thing saying, hey, it ran correct, but you didn't put any parameters or queries or body stuff, so I'm not going to do anything. This is stupid. The only non-PowerShell thing in this script is this here, where we're essentially using a .NET type of HTTP response context. So it's returning a correct HTTP JSON object back to the end user. So we're essentially giving it a status code. So is it okay? Is it bad? Did it fail? And then we're also providing a body of content. In this scenario, it's just going to be a string. So it's either going to be, hello, my name is blah, or it's going to be, you're an idiot, you didn't do this correctly. The other things that I want to look at, actually, let's just do these quickly now. I'm going to go into task, run task. You get this again for free with all the stuff. It just exists and builds you this task. All right, so my terminal is, we can see we're building things here. So cool, this is working. Open in browser. Your function 4.0 app is up and running. For anyone that's following along, are they at this point? Is anyone having any problems? Sorry, give me 1 second. Let me kill this. Control C. Okay, so task, run task. There should be an option there called func host start. You see that? Excellent. See this cool option here, make public? I can actually expose this out running in a code space instance so that other people can use this thing. It's insane. Okay. We're all good. I think there's probably like 4 people following along, which is great. Okay, so here we've got 2 methods that we, just by default, that we get. So we get and a post against this local host. So let's grab this, and then we're going to go into our handy dandy API Explorer. That's fine. It should be fine. And we're going to find Thunder clients, which is my favorite API tester. We're going to create a new request. Okay. We're going to do a get against this API. So localhost 7071 API HTTP trigger 1. Query parameters, I'm going to say name. And the value is going to be Ben. Check that out. So we've got a 200 OK, which means everything is good. The API worked the way it's supposed to. We've got our string result. Hello, Ben. This HTTP trigger function entered successfully. We've got information around how long that took. 1.54 seconds. It's not very fast. But the more you do this, and obviously once you ship this into Azure, it becomes a lot faster. But there's a lot of back-end stuff running here. Let's try another thing. So this is just a query. Note how when I put in the query parameters here, it actually built the API request. So it put in $name equals Ben. Let's get rid of that. Let's do it as a body, because if for anyone paying attention, we had multiple options to do this. So I'm going to just create a little JSON blob. I'm going to say name equals Scott. Hit send. See how fast that took that time? 34 milliseconds. It's because Scott's better than me. All right, so we get our string response back. Hello, Scott. This HTTP triggered function executed successfully. Note the URL did not change. We simply sent a body of a payload data as an additional thing in that request. So instead of having a giant long string with all the query parameters, we just gave it a JSON payload. If I put nothing in and I just do a get, it ran, but there's nothing there to do, so that the code just did nothing. Does that all make sense? Awesome. Let's try post. Lowercase. All right. Cool. It ran, but the code itself isn't going to do anything fancy. It's just another way to get in. So in theory, a post should do something. So, okay, now that we know that this is functionally working, let me show you a couple of other things around how we can actually control what we're allowed to do with this. I'm going to close this down. Is everyone going okay? Awesome. I'm going to cancel this for now. So to close the Azure function that is running on your computer, just go into the terminal and press Control-C, and it will bin out the Azure function and tell you that you can just press any key to close the instance. So it's now no longer running. Okay. The next thing I want to point out here is that when we ran the Thunder client, we actually got a couple of different ways to get into our Azure function, which was get and post. That isn't just made up. That is absolutely configurable. So if we go into function.json, this is the configuration for what we're actually allowed to do here, right? So this is our trigger binding. So we've got a HTTP trigger. Direction is in. The name is request. And the methods that we're allowed to do are get and post. So what I can do here is I can actually start putting in things like put, thank you AI, patch, and delete. So now I'm allowed to do a bunch of different things. So if I save that, and then I run my task again, so Command-Shift-P, or F1, run task, function host start. Note that we've got get, post, put, patch, and delete here. So that's expanded what we can actually do with this function app. So this is every single core thing that we will need for our Azure function app that we're going to be building here. Okay. Let's kill this again. So Control-C. All right. So let's actually start doing some interesting stuff here. I need to know, so the way that I want to do this is I just want to have two function apps. I want to have my, again, going back to the schema, the design that we had, I want to go and I want to have one that is just on my to-do route, and I want to have one that is on to-do/ID. So I want two function apps. For the first one, I want get and I want post. For the other one, I want get, post, put, patch, delete, all the things, because I'm doing all the stuff to units of data in my database. So let's figure that out. We need to figure out exactly what we get in a request, because I don't want to write a function app per thing. Absolutely, you could do that. You could create a function app for every single get method, post method, and things like that. But generally, as far as design-wise, when it comes to APIs, you're scoping things to what the endpoint is. So if the endpoint is the same, then it lives in the same code space. So that's what we want to do. What I will do is let's have a look at what we actually get in a request and a trigger. Let's go into run. I'm actually going, okay, for everyone that's following along that doesn't want to change branches now, I'm going to kill everything that I just did. We're going to go over to number 2 now, Azure Function. And give everyone just a little bit of time to catch up. Okay. This code here is the exact same thing. I have secret stuff in here that we're going to copy and paste. So what we're going to do is we're going to get rid of the default stuff, right? Just kill that. All of it, actually. All of it. The entire region. The function now does nothing. Okay. What we're going to do first of all is I just want to look at what the request does. So let's just copy this. Okay. So I've uncommented that. For anyone that just wants to do exactly what I did, that's Command or Control KU automatically unselects or uncomments things. It's kind of cool. So what we're doing here is we're changing what the body is. So here, I want to just create a very basic JSON payload. Okay, I want to have two things. I want to have a request and I want to have trigger metadata. If we have a look at the params, we have request and we have trigger metadata. All I want to do is I just want to see what I get for free. What is the actual framework behind this Azure function and what can I work with? So I just want to see it. I'm going to convert that to a JSON file and then I'm going to push that out. I'm going to say hey, status code is okay and the body is just body. So we're just going to save that, and we're going to run. So again, go into the command palette, task, run task, function host start. My timer has kind of run out. I don't know how I'm going for time. Anyone? When am I supposed to finish? How long? Cool. Okay, perfect. Okay, so we've now got a terribly named Azure function that has get and post, because again, this is just the default thing, and we've just changed the intent or what is going to be returned to us. So let's go back to our, we're going to go back to our Thunder client now. It's really, really hard to work in this resolution, so let's figure out how to make conferences better, yeah? New request. Get this. Actually, I can cheat a little bit here. So one of the cool things about Thunder Client is every single time you make a new request, it actually keeps the activity or the history. So I can just go back to this one. And it brings back to the exact request that I made. So let's just get rid of this because I just want this. So we're going to do get against HTTP trigger 1. Send. Status 200 OK. The payload size is 1.6 kilobytes, and it took about a second. We run this one more time, 25 milliseconds. It's always slow the first time because it needs to build a bunch of things. This is how the consumption API Azure Function framework works. The first time you do it, it's called cold start, and it takes a little while to get the stuff that it needs. Once it's all in memory, it's real snappy. Okay, let me just pull this up as much as I can. So now we've got a JSON payload back with request as our primary thing, and I can actually shrink this down. And we've also got trigger metadata. For today's session, because we only have 45 minutes, just know that request is the thing that the metadata that we get from you. The trigger metadata is things that the unique trigger that we have, which is the HTTP request, also gets. For this scenario, the trigger metadata and the request metadata are basically the same. But if you were doing an Azure function that did not use a HTTP trigger, then the trigger metadata is totally different. So if you're doing blob storage, things like that, it all starts looking very different. So we can see, so inside the trigger metadata, we have just a duplicate instance of request. So we don't need to worry about trigger metadata for now. That's throwaway. We've seen what it is, but that's cool. Let's have just a quick look at request. So we're going to open this up. All right. So on this request that I did, body, there's nothing there. Headers, yeah, we've got a couple of things. We're going to accept the connection was closed. What was the host? What was the user agent? See, we're using Thunder Client. Just a bunch of things. How did we hit the API? The method is get. This is important. This allows us to write a single script, and then based on the method, we can do different bits of code. So we can just write a switch statement or whatever you want. So this is what we want to grab. And you're like, okay, does this change if I change my post, if I go post? Hey, it does. Method is post. Okay, cool. I've got a thing I can key off now, and I can actually write my code so that if I change things, it's going to work. Other things that we get, the URL that was actually sent that request through. We get params. This is important for later. We get query. We get raw body, which is just unstructured data. So this is everything that we need essentially to know what the user is sending into our API, how they sent it, to dictate what we actually do with that. So let's kill the function app. Actually, let's try one more thing. I think I already showed this. But if I just run a method that doesn't exist, 404 not found, it just immediately fails. So this is a really strong structured way to say, well, my API can only get and post. I don't want people to do updates, and I don't want people to delete. You immediately lose that functionality with this, which is kind of cool. Okay, let's pop out of this. I'm going to kill the current running function app. Just, again, Control-C. Go back to run PS1. Again, we're in branch 2. And I have another section here. And I'm just going to grab and uncomment. Control-KC. Or Control-KU, rather. Okay. Let's just comment this, because we don't need to duplicate. What we're doing now is, again, remember we had the request, inside the request JSON payload, we had a property called method. So I want to key off that on my switch statement. So we're not doing anything here, but we're saying get, post, put, delete. I'm just storing a string in this variable called body. And then my final thing, I'm just sending the body back. So let's see what that looks like. So if this works, then we can actually start building our script. Okay, it's all good. I'm just going to see if we can, don't show again. I hate you. All right, cool. Everything's looking good. Let's go back over to this example. Okay. So, actually, quickly. So, we've got get, post, put, and delete, and default, okay? My function currently only allows me to do get and post. So those switch statements will fail. We'll never get to them. So the default value actually never, it's not important, but for code quality and clarity's sake, whenever you're doing a switch statement, always put a default in, because what if something goes wrong? You need to be able to handle that request in some way. Okay, so we're just going to go to get, send. Hey, we got a string back, get. And the emoji is very small, but they are 2 beers clinking together. Okay, we're going to do post. Cool. The emoji is sending something in the mail. Happy days. Again, to show, even though we set the code up specifically to allow us to do this, we go to delete, it fails. So let's fix that. Let's go in and we're going to add those fields back just to verify that it's going to work. Again, I'm just going to kill my function app. Go into function.json. And we're going to add, we'll just do them all. We're going to do put, patch, and delete. Okay, again, rerun everything. Okay, let's do it. We got delete here. Delete. Trash can. Fantastic. Everything's looking good. Let's go patch. Unknown. So I didn't specifically state in my code that patch would do a thing. So it's actually been caught by my switch statement. It says it's unknown. So we can actually handle, if we've configured our function app incorrectly, we can handle that sort of scenario. The other thing I wanted to just quickly do, I'm just going to go back one step because I totally forgot. Because, again, awesome. Just Control-Z. I want to show you what the payload data looks like when we add queries and bodies and things like that. So we're just going to go Command-S, run task. You can go away. That's looking good. Back to our thing here. I'm going to go into get. I'm going to go in, first of all, let's do a query. Name. Ben. Send. What does that payload data look like now? So what we're basically looking for now is because, hey, I don't know what the actual trigger metadata is, and I need to be able to figure it out before I write my script. Okay, so I need to know where these things come from. So let's have a quick look. So in the request, we don't have anything in the body. If we scroll down, we've got nothing in parameters. We do have query. So we've got query and name. Fantastic. So if someone hits our API with dollar and puts in data, then we can key off that. What does the body stuff look like if we do that? We can actually, we can get a little ridiculous with this. So we're going to keep the query. We're also going to add a body. Okay, so now we've got our body, name is Scott, and then we've also got our query, name is Ben. So we can actually key off this data and figure out what we're going to do. You can control exactly what you want to work with. So if people start putting in rubbish data in the query, you can just ignore it and never use it. So there's no scenario where people can do sneaky stuff with this as long as you make sure that you only want to focus specifically on one thing. Okay, I'm going to close this. All right, so the next thing that we need to do is we actually now need to start building things. So we know right now that we can figure out what the user's intent is with the method, and we can figure out what the payload data is that is being sent, whether it's through a query or whether it's through a body request, okay? That is all we really need for this. So the actual payload data that we're going to be working with today is just a to-do item. So all we're going to have is a property called task, and that task is going to be the thing that you want to make sure that you get done today, all right? So from here, what we're going to do is we're just going to delete everything that we've just changed. Discard all two files. And we're going to switch over to number 3. I'll give everyone just a minute if they're following along. Close a couple of things just to make this easier for me. Okay. All right, so now you'll see that we have 2 function apps created. So what I did to do this is I just went into Command, Shift, and P, and I just said Azure Functions, create function. So we're not creating a new project this time, we're just adding a new function. I'll just quickly show you what this looks like, but you can also do this yourself. We're just going to go in here. What is the function? It's a HTTP trigger. What is the name? Give things better names. Run, authorization level. And then we can see we just have a folder structure now called give things better names. So this allows you to build as many functions inside the single function app that you need to do. And this is what we're going to do when we build our 2 different routes. We're going to have one that's just to do, and then one is going to be to do ID. So that's how we do that. So let's have a look at HTTP trigger 2. I'm just going to delete this one. Delete permanently. Okay, so ignoring HTTP trigger 1, because that is just our demo code from what we just looked at, we're going to look at HTTP trigger 2. In the run command here, okay, so again, nothing different. We've got request and we've got trigger metadata. This is where we start getting tricky. This block here is how we will handle access to our storage account when we run this in production. So for the people that were in my session yesterday, when you have a managed identity in an Azure function, it stores that identity in an environment variable called MSI secret. We know that because if we go into profile.ps1, this is a thing that runs, and it literally says it in the comments there. This profile will get executed every cold start. So that's that slow initial run that we were talking about. The things that happen in here exist for the entire lifespan of the function. So for free, this just immediately comes. When you build a function app, you get this block of code. If MSI secret is there, then we're going to do some things. We're going to disable AZ context autosave so we don't leave payload data about the identity lying around, which is a good thing. And then we're going to connect AZ account identity. This is the magic trick that allows you to use managed identities in function apps. It's 4 lines of code. So we're just connecting. We have an identity. If you want to change the scope or the permissions and things of that managed identity to do other things, you can then grab that identity and swap it around. Question? Sorry, what was the question again? So the question was, is the MSI secret for a system managed identity? So I haven't tested it with user, but I'm fairly confident that it is the same thing. It exists in the instance as just an MSI secret. So it doesn't matter whether it's user or system, yeah. So this is our sort of magic trick that we get access to that. So if we go back to our run window, I'm just doing the same thing. So I didn't figure this out. I just looked at the profile and I copied it. I'm using a couple of different existing AZ functions to do this work because I don't need to write my own stuff. In an Azure function, you need to define, hey, I need these modules to exist in my run space. So to do that, if we pop over to requirements.psd1, here we've got a list of things that need to be in our function app environment for this function app to run. I've got a couple of things here. I've got AZ accounts, AZ storage, AZ resources. So on cold start, it is going to go to the PowerShell gallery and pull these things down. Note that all of this is default. It suggests that you can uncomment and grab AZ. Never do that. The AZ PowerShell module is huge, and it will take about 5 minutes for the first cold start run to happen. Don't. Figure out the exact parts of the AZ modules that you need and just specify those. You can obviously change the versions, you can do all that fun stuff, but this just means every single time the function app runs, we're going to have that state, and we're going to have the exact tools that we need for this to run. Okay. Inside profile.ps1 as well, if anyone's just poking around, we've got some nonsense that I added because I like to over-engineer things. I've gone ahead and I've created a custom class called ToDoTask. Inside here, we've got this task is a task and completed. And then I have a table entity just so that I know that when I'm doing these requests. Oh, question. That's okay. Yes, absolutely. So the question was, when you specify a module in requirements, if those modules need other modules, then yes, it will pull it down. Absolutely. So again, that's why AZ works, right? Because the AZ module, if you actually look at it, it's just an empty PowerShell module that says requires and pulls down 400 different things. So yes, it absolutely works that way. Thank you for your question. Yes. Excellent. Okay, so wasn't a question, but it was basically saying there is a way that you can actually just have your own modules. You can put them in a specific folder, and then you just get access to that stuff. The only problem with that is that natively you need to use the what's it called? Kudu thing to go. It's complicated to put the modules in the directory. You can't just do it in VS Code. So one trick is you just dump it all into profile.ps1. And this is going to run and it's going to exist. So if you've just got a couple of helper functions that you need, just chuck them in here. When it runs from cold start, you're going to get that stuff. If it's more advanced, then yes, absolutely, you'd look at that avenue. But for this scenario, I've just got some things. So I've got my classes, and then I've got some custom functions that I'm actually using to work with Azure Tables, because the default ones do not work with managed identities. Awesome. So feel free to grab this. I did not write this. Here is the link for the person who did. Maybe he's here. I don't know. But this is fantastic, and it meant that I didn't need to write it myself. I have a solution that I wrote myself, but his auth works for managed identity. So I just copied and pasted it. He hasn't published it to the gallery. So I can't just pull it down as a required thing. Otherwise, I would have done that. So if anyone knows this guy, thank him and then tell him to publish the code. But yeah, so if we have a quick look at our profile thing, because I feel like I'm talking too much. We've got a bunch of helper functions that are all underscored. We don't need to look at those, but we do have in here update storage table, add storage table, remove storage table, get storage table, and get storage table row. Yeah, next row. Should also have delete, but I don't know why that's not there. But that's fine. It might break. That's all good. So, okay, so our profile has got all the things, the helper functions that we're going to do so that our run.ps1 is a little cleaner. So let's have a look at the run.ps1 now. So we've got our auth context. That's cool. When we're running this locally, again, for anyone that wasn't at my session yesterday, you can't use managed identities locally. It's an Azure thing. So when we're developing this locally, we can't get the identity, so we just fail over and we go, okay, well, now we need to start storing some stuff, some secrets in our environment, which is the thing that we shouldn't be doing. But if we want to develop this locally, we need to. So I actually have a local, so what everyone needs to do is, for anyone following along, find my notes app, go here, qrcode.de/pwsh. This is going to send you to a gist or a gist with my secret information, so my table data. So again, for the people that don't have Azure stuff, you can still follow along. Go here, grab the content. I'm going to do it as well, just to show you how to do this. Copy. Okay. Again, I've got all of my secrets on the screen. It's fine. I'm going to bin this later. Everything's all good. But essentially, what we're going to do is I'm just going to grab this code, copy, go back up to your instance here. Now, in the root of the src folder, create a local.settings.json folder. If you were following along and if you're at this level, you may already have this file. Awesome. Just go in here, select everything, paste this in. This is the production local environments content. Now, when you create this, the local.settings.json file does not get ingested when you do git commits and things like that. So this is safe. It's on your machine. So as long as no one steals your laptop, then you're good to go. This is how you do local development. Okay, so we're just going to save this. The important things that we're looking at here are some custom fields. So I've added table name is to-do. Storage account name is PSConf23C8A. And then the storage account key is the account key from this. You actually get access to the storage account for free by default. It just has Azure Web Job Storage. So the function app itself uses the storage account to do stuff anyway. So we can just leverage that, which is kind of cool. Okay. So I think we're good to go. We've got all that set up. Let's have a look at the run now and let's just see what we're actually doing. Okay. So locally, we're going to say new AZ storage context. Storage account name is the storage account name. The storage account key is the storage account key. Once we have that context, I'm just dumping out a bunch of stuff to the screen to make sure that that's correct. We don't need that anymore. We need to get an instance of the table or the table context. So we're going to say get AZ storage table with the table name, which is to do. And then we're using the context, which is essentially our authentication. So, hey, we have used our managed identity or our local thing. Please give me the table data. And then, based on what we just did in the previous one, we're going to switch around. So we've got two things in this example. We've got a get and a post. Because if we remember what the initial design was, the first top-level endpoint is get me all of the tasks and also add new tasks to my thing. So this is what we need to build. I have a cheat sheet in here, if everyone has a look. Cheat codes. Here's my code. I'm just going to copy this and we're going to have a look at it. So copy. No, we're going to go. Okay. Scroll down all the way to the bottom. Sorry, I did this frantically before I jumped on a 200-hour flight. So, okay, so we're just going to copy the advanced region. Copy. Going into run. Whoop. Find this one. Control V. And let's just fix this. Looking good. It's looking good. Okay. So what we're doing now is when we hit get, we're going to try a couple of things. So we're going to try and get just the table storage row. Find any instance in our table with a partition key of to-do. So by default, Azure Tables are broken up by a row key, which is just its unique ID. And then it also has a thing called a partition key, which allows you to say, hey, get me all of the data, but only get me a specific thing. And it's like it's indexed against those partition keys, so it gets a little optimized. So what we're just going to keep it as to do as our default thing. But you could potentially, if you wanted to build this out further, you could say your partition keys are based on the state of the task. Is it complete? Is it not? So then you can actually just pull back the complete things. So you can actually build on this. Once we've got all of our results, because I'm an idiot and I overcomplicated this stuff, I'm going to create a generic list of to-do table entities. I'm then going to step through the results, and I'm going to add every result of the Azure table into that list, and then I'm going to store that as a variable called body. I'm going to give it a status code of OK. If I get any problems with this, I'm going to change the status code to bad request. If we do a post, it's kind of the same thing. It's kind of a little simpler. We're going to say, okay, well, if there's nothing in the body, and this is where I'm being controlling where the route is, then I'm going to immediately fail it. Bad request. There was nothing sent to the API for us to process. So try again. If we do find something in the body, then we're going to create just the parameters, again, because this is how we should all be writing our PowerShell. We've got our table, which is table. Partition key, we're going to call to do, but you can call it whatever you want. Row key, I'm just using GUIDs because it's nice and easy. It needs to be unique, otherwise it will fail. And then the property is task equals whatever's in the task. And then completed, which is our state value, is just set to false by default because it's a task that we want to do. It hasn't been done yet. So by default, we're just going to set it to false. Again, once we've created that stuff, the post result goes off. Note that we're saying return content. This is kind of cool. So with the function that I stole from someone else, we're just modifying the request to the Azure storage instance and saying, hey, if this works, can you just give me the actual payload that we just created so we can actually see it, which is great. You can omit that if you want, but it's good for us. So we're just going to load that post result into the body. We're going to say HTTP status of created, method not supported if we end up with a route that's incorrect. And then finally, we've got our output binding. So this should be fully functioning first part of our thing. So let's save everything. All right, again, run the function. And if everyone's using my table and it's already gone ahead of me, then we might actually see some stuff in there, but who knows? Okay. This is, I forgot to show a thing. Okay. Everyone note that we're working on a function called HTTP trigger 2, which is terrible. Never just use the default names. Look at the endpoint here. HTTP trigger 2 is actually not going to HTTP trigger 2. It's going to do. How did I do that? Okay. This is good. This is something that isn't really super documented, and it's kind of annoying, but if you're doing it in VS Code, you get the autocomplete on the configuration of this. So if I go into function.json, again, we looked at this very early on about how I can control the methods, get and post and things. I've added this thing called route. That allows you to override the default route name for your function app. What's cool about this is it gives you the ability to go, well, what if I have dynamic data? So we can go in and we can go ID. So now, if I ran this, it would be, the endpoint would be constantly looking for to-do, and then whatever's after to-do gets sent back to PowerShell with the property of ID. So it's just a PowerShell variable or a bit of data that we can key off. And that's how we get the second step. So we'll send that back to normal. Okay, so we've got our thing. Let's go into Thunder Client and see what's going on. How am I going for time? I thought someone said 15 more seconds, and I'm like, okay. Is everyone still very confused? Always? Okay, that's awesome. Okay, so we're just going to go in here, API, to do. Let's delete our JSON payload, and we're just going to do a get. Takes a little while the first time. Hey, there's already something in there without a task. That's cool. I can... Okay, well, I'll remember to do that because it's in my to-do list. So give me 1 second, we'll update that. Well, you guys get me a coffee. Okay, I can get whoever said that. One of the things I was going to do is I was actually going to tag this with the person who did the request so that I could actually chase people up on this. I didn't do that. It's fine. Anyway, we already have a bunch of tasks in there. We probably should have error handling so that if the task is empty, that it bombs out. At the moment, we're just saying, if it's an empty value, then that's fine. So we just need to do a little bit of error handling on that. But let's just go in and we'll create one now just for the people that aren't being sneaky. All right, so again, we're just doing body. And we're just saying task, get me a beer. Okay. And we're going to run that. So again, we've set that to post, and the API is to do. We're going to run. 506 milliseconds, which is still kind of slow. Get me a beer. Completed as false, so no one has got me a beer. If we just want to quickly check that actually went into our, we know it went into our table because we know what the code did, but let's just look at all of the results now. So we can scroll through. See the top one there? Get me a beer, along with all of the other things. So this is just an array of stuff that we can do. So now we're at a point where, okay, we're now starting to feed data into this beast. If we have a look at our table store here and refresh this, oh, come on. Oh, okay. No, this is fine. Switch to access key. We've now got all of that data, which I think is kind of cool. So you can now physically see this in our database that we've got a bunch of tasks. We've got timestamps. This is unstructured data, so you don't need to go and set the schema for what this is. If you start adding extra fields, if those other rows don't have those fields, they'll just be empty. So you can just build this out as much as you want. It's really, really designed to be idiot-proof. NoSQL databases are fantastic, although I know that there's some SQL people in here, so there's room for both. Okay, and we can see that we've got our completed value as false. This is all just string data. You can do schema-e things, so that's kind of cool. Okay, so let's go back to our code. Really quickly get this done so that we can try and look at some of the code gen stuff. Okay, so this is great. Let's kill this. So we're happy with the first endpoint. So now we need to build the more advanced thing, which is that custom route. It's not more advanced because I kind of showed you the cheat to it, but we're just gonna kill this. And again, for everyone that's following along, we're going to remove any changes that we made, and we're going to pop over to number 4, which is the ID routes. Okay. So now I've got a third trigger. Again, I didn't name these things correctly. I'm a terrible human being. If we go into function, we can see we've put all of the methods, so get, post, put, and delete. They're the ones that we want. And we've got to do and ID. So this is going to grab whatever is at the end of that slash, and it's going to put it in as a variable that we can work with, which is exactly what we need. So let's have a look at the run.ps1. None of the other things have changed. The profile is exactly the same. The requirements are at a top level, so you don't need to do this per function. So this all just works. Nothing really changes here. We've got our context. We've still got our debug stuff. But here in the request method, we've expanded this out to get, post, put, and delete. So, again, it's exactly the same. So let's go to our cheat codes. Let's see, I think I just put these all in. Yeah, I did. Okay, so we can just grab the whole thing, copy, go into run, grab this. Okay, let's have a really quick look at the code now. At this point, it's kind of not necessary about how the code works. It's just showing that it works, but okay. So we know that get and post, in theory, you'd be like, well, aren't they just the same? Well, no, they're not, because we're doing different things here. So when we hit this endpoint, we're saying, actually, please just get me one instance in that table. I don't want all the things. I just want one thing. So what we're actually doing here is, let's have a look here. So we're grabbing the parameter value. If you cast your mind back when we were looking at what you get in the request, that empty field that never got filled in was parameter. Params only get filled in when you add those params to that specific route thing in function.json. So it just exists. It's a thing we can do in params. It's always going to be ID because we configured it specifically to be ID. If you give it a different name, it's going to come back as a different thing. So we've got that. We've got post. Again, we're just using post to switch the state of this, just as a toggle switch. So when we do a request, we're just going to get that item, and then we're just going to grab the property of completed, and we're just going to toggle it. If it was true, it's now false. If it was false, it's now true. So this just allows you, if you wanted to scaffold out a front end, every single time you did that checkbox, you just send a different request. Probably not the best way to do it, but it's fine. The post is exactly the same. We're just going to grab the data, and we're going to fill out that request, and we're going to send it off. If everything's all good, we send an OK. Otherwise, if we didn't find that instance, then we're going to send back a not found. Put is how we're going to modify the task name. So again, the only thing that we're doing here is we're just going to send through that initial task with a different text field along with the ID of the thing, and it's just going to replace the task name for us. And then finally, delete. We're just going to delete it. If it exists, we're going to throw it in the bin. Everything else is very simple. So let's go in and have a look at this. Run task, function host stuff. All right. So we can see we've now got our trigger 2 and trigger 3. This hasn't changed. This is the new one. So let's just go and verify that that's all true. Go into get. API to do. Let's just make sure everything's working correctly. Again, we're doing that cold start, so it takes a little while the first time. 3.39 seconds. If we do it again, 588 milliseconds. Fantastic. So we've got all of our rows. Applaud for a great session in 10 minutes. One of the things you get for free in Azure Tables is timestamps as well, so you can see when this went in. You don't have to worry about that. It's just there for free, which is great. So what we're going to do is we're going to let's find Dart. This is great. Okay. My dongle just fell down. That's what she said. Okay. Copy. All right. So we're going to do the same thing. Get /ID. Sweet. It came back. Note that this is not an array anymore. It is just a single JSON item. So we've got our partition key. We've got our row key, timestamp, property, task, and completed. Okay, I've got my task. I don't know what I'm supposed to do with dar, but I've done it. Okay, so let's close it off. We're going to go delete our body. We're going to go into post. Completed is true. Let's go see if that's actually correct. It is set to true. We can tick that off our bucket list. It's done. If we stuffed up and we actually meant to keep that open, we can just go back in. We can just run this one more time. That's going to set that completed value to false. Super simple. The code is very basic, but hopefully you're understanding the idea of these custom routes allow you to work with unique objects in the environment. Let's have a look here. Okay. I want to look at all the things again. I want to find another good one. I'm sure everyone's been slamming it. T-shirts. I don't know what you're talking about. I don't like T-shirts. All right. Okay, this one. This is a duplicate. So we're going to delete it. Because if you ask too much, no one gets T-shirts. All right. So we've got our ID. We hit send. 204, no content. This is a default standard experience in an API world. When you delete a thing, you just say 204, it's done. It's all good. You don't need to actually send back. There is no data to send. As long as it's 204, happy days. So we're happy. That's gone. We can check. Let's see if we can find it. There's one of so many T-shirts. All right, let's refresh. I think it went from 23 to 22. It definitely did. T-shirts. Okay, nice. Where's the beer? Yeah. Okay. Now you're awake. Okay, excellent. All right, so that is in depth how to sort of build a custom routing so you can actually start doing. Really, that's the baseline for an API. The next thing that we need to do, how long have I got? Is it literally 3 minutes? Okay, I will quickly show you how this works. It's not going to be pretty, but the idea here is that now that we have this, we need to create the metadata that defines what a request looks like. And then we need to generate what is called an open API spec document or a Swagger document, or there's a couple of different names, there's a couple of different technologies around this. What that is just a JSON object that defines every single part of what that API is, what a payload is supposed to look like, what you're allowed to do with it, what the return codes are, all of those things, so that you can then throw it at something like auto rest or nswag. There's, again, catchphrases for days. There's so much tech in this space. Once you've got the open API document, you can build clients in whatever language you want, PowerShell, C#, you could do JS if you want, and it will work. It will just natively work. So you can send this to your front-end dev. They can build a JavaScript client, build their front end, and then you've got an app that you can sell for $6 on the store because everyone loves a to-do app. So let's quickly see if we can get this working. I'm going to go into here. This is absolutely untested, so let's see what goes wrong. Okay. And what I found really interesting with doing this was that we're kind of working backwards from where you would normally do this in C#. Whereas in C#, you kind of define the routes that you want and what the expected things are, and then you build the code to make it work. Obviously using unit testing and all that sort of fun stuff. Whereas what we've done is we've built the back end, and now we need to build the definitions for those things. So it gets a little confusing. And also the UI for this is terrible. I don't know who's in charge of it, but I would love to have a conversation with them. Okay, so we are now in our function app. What we're going to do is we need to start building this stuff. We're going to go into API management. I might not remember how to do this. Do I already have one created? I do. Do I trust it? Yes. Okay, I don't have an API thing in there. We're going to make sure that we're going to import the functions. We're going to link API. Check this out. It's found the functions. We don't need the first one because that was just junk functions, but we've got HTTP trigger 2, get and post. HTTP trigger 3 gives me get, post, put, and delete. That's cool. One thing I didn't show you is how to deploy this to Azure. One second. Command-Shift-P. Func deploy. Deploy to function app. Hit this, sign into Azure, point it at the function app that you've created, wait 3 seconds, and it's there. Your code is there, it is secured, you can't change it from the front end. It's fantastic. I can talk about that a little more. I can show you demos after this, but we're running out of time. Okay. Is everyone still very confused? Excellent, good, so am I. So we can see we've got our URL templates, our routes. We're just going to select those. Okay. So we're creating from function app. Display name. My name is Ben. API URL suffix. So this is actually creating a front end so that whenever you make requests, it's going to tunnel through this to manage your function app and send the request to the function app. So this is the management plane for your API. API management costs money. There is different levels. There is a developer one that is free, but it is very slow to provision. It is meant to be used for testing. There is a consumption-based one that is very cheap, but this is where you start going, well, I'm now doing production level stuff, so I'm going to have to start thinking about costs involved. So I'm going to go to create. I have 48 seconds. Let's see how we can go. I'm sure this is going to take a while. All right. So check this out. So from those functions, we've got a whole bunch of posts, get, put, delete. And note the names are all there. It's HTTP3. So again, name your things correctly. Don't be me. Be better. It's very easy to be better than me. But let's just go in and we'll have a look at one. So post. What we need to do, so you can see here by default it's post to do, right? So this is our documentation process. We're going to go into the front end and we're going to customize a couple of things here. So display name, let's make this better. Okay, the name is whatever, that's fine. The URL is post to do. Description, we are going to post a task. Cool. If you want tags, you can do tags. We got template parameters. Are you expecting anything? Yes, we have a payload that we're expecting. So what we want to do is we want to go into request, description. Yes, request payload, sounds good. Representations. So what does our data look like? Because we want to make sure that the people using our API know how to actually use this. So we're going to go in. We're going to go application, JSON. Now it's asking for a sample. I'm actually going to, oh, it's fine. We'll just do it this way. So if we go back to our function app, we go into our, let's post a new one. Because we wrote the code, we know how this works. Going to go into body. Task is hurry up and finish. Because I'm over. So we're going to send. Okay, cool. We know that this is what we need because it worked. Command and copy, or control copy for everyone else. We're just going to paste this in here. Okay, that's our sample, and we just hit save. Now that we've created that, and this is where I get really frustrated because whenever you make changes to this, there is an open API spec that has already been created. The only way to get to that, and it's a global one for all of the different things, is you have to go into one of them, go into the front end, edit, and go to Open API Spec View. That's frustrating. It's a global thing. It shouldn't be on a unique thing. But anyway, so now if we have a look here, we have built a JSON Open API spec of version 3.0.1 with our title, our description, what the version number is, the URL for this to actually work, and then we've got our paths to do ID. We've got delete. We've got responses. So this is all just default stuff, right? It's not going to be super helpful. We need to go into every single route and customize this, and that takes time, but this is documentation. Documentation is important. The cool thing about this is the documentation makes the code for you. So it's even better. If we go down to our post, let's try and find the one that we did. Let's have a look here. Okay, I think it's this one. Post, okay. Summary, post a new to-do task. Description, we're going to put a task in. Operation ID, request body. What does it look like? This is an example. It has to be an application JSON format. The example here is task hurry up and finish. You can actually put in these schemas so that if you don't fill in the body correctly, it will fail. You need to write the code to handle what happens when that fails, but when you build this client, it will know instinctively because it will build that error handling that if the task doesn't look correct, it's probably going to fail. You need to also put in the documentation that if something fails, what does it look like? Does it return a 200? Is it a 404? But essentially, it's in your power now to create this document, and then you can give that to other people, and then they can build their client to work with your API. That's kind of cool, right? This all basically costs us nothing to do this stuff. So this time next year, when people ask, are you guys working with Azure Functions? I want a lot more hands put up. Or just, I'm still confused. That's fine. You got 365 days. Okay, I'm going to finish now. Does anyone have any questions? Because I'm running way over and lunch has started. You got a massive errors? Sick. We can go and have a look at that after this. All right. Thanks so much, guys. This has been a weird experiment.